Well, if you look at it, it's 1, well, 0x1, 0x2, that's all zeros. So it's just 1x4, in other words, x4 has to equal 8. And that really, really shows that x4 cannot be a parameter because it has to equal 8. It can't be whatever it wants. Now look at this one. What does this equation, this row read as?
x2
equals 9x3.
9x3.
9x3, yeah. So it's x2, 1x2 plus 9x3 is equal to 3. And we've already said that x3 is the parameter. x3 is equal to t. So x2 plus 9t equal to 3. And all you want to get x2 on its own, take away 9t. x2 is equal to 3 minus 9t. As I said, you can go a bit faster than that. Some people will go straight from there to there, and that's absolutely fine. They'll just say x2 is equal to 3 minus 9x3, and x3 is t. That would be fine. And what does the first row read?
x1 to 4 is 3.
Correct. And you know what x3 is? So you have x1 plus, we're calling x3 by t. And all you need to do is take away the 4t from both sides. x1 is equal to 5 minus 4t. So you have x3 is equal to t, x4 is equal to 8. Now x2, it depends on what x3 is. x2 is related to x3 like that, and x1 is related to x3 like that. Now if you do that, you get full marks. Yeah, let's just leave it at that. T can be any value at all.
So JP, we just says in the start there to write down the associated linear system of equations.
Now, funny enough, I never did that, but they are here. There's the third one, there's the second one, and there's the first one.
Like, does it want you to write out x1 plus x4, x3 is equal to 5, is it?
Yeah, I'd say,
I
I think you're right, but it is in there. You're right though, I probably should have done that first, but it is much of a muchness. It's a bit, it's clumsy. I mean, it's there.
If you wrote the x1 like you have there, would that kind of do you?
This is fine, yeah. If you want, you could write out that equation, then that equation, and then that, it's the same thing. Any other questions on this?
Just the first thing, x3 equal to t.
Yeah. So again, once you know you have solutions, if you have a 0, 0, 0, 0, non-zero, that means no solutions and you're done. If that doesn't happen, you do have solutions. You look at the pivots, pivot, 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 anything without a pivot, x3, that is a parameter. It can be any value at all. x3 can be any value at all.
Okay.
So x3 is a t. Now you can, it won't happen in your test, you can have 2 parameters, and 3 and 4, but that won't happen t. Okay. Right on. Secondary school wants at least 18 buses with a combined carrying capacity of 990. 3 available types of buses carry 20, 35 and 65. Probably the hardest thing here, and the thing people most make mistakes with, and what leads them into problems, is when they don't correctly identify X, Y and Z. So I'll write out something and we can fix it after it. So what you get a lot is stuff like X is equal to, even X is equal to 20, Y is equal to 35, and Z is equal to 65. People writing something like this. That's nonsense.
But you, the example you done earlier on at the start of the class, because I was only looking at that the other day, that's the way you've done it yourself.
No, it's not. No. The number of 20 seaters. The number of 35 seaters.
Oh, sorry, you had this sort of
yeah.
The number, yeah.
Because they write this. Now the problem is when you write something like that's saying that X is equal to 20. It's very bad maths. And while a lot of people writing something like that, they end up writing actually the correct solutions and they do solve it. a lot of people just get a bit confused. Be very, very clear. X is the unknowns here is how many 20-seaters, how many 35.
You doc for that, would you, if the number symbol wasn't more?
Yeah, just we were running it.
I'm just curious because
I wouldn't have to because
I
some
concentrated
people
more on
would.
the numbers when I was looking at rather than that actual number symbol.
Some people, I wouldn't have to because some people who don't do it will not be able to do it because it doesn't make sense.
So, x plus y plus z is 18.
Spot on. There's a man in a hurry. So the total number of buses is 18. So the number of 20-seaters plus the number of 35-seaters plus the number of 65-seaters is equal to 18. And of course, if x is 20, y is 35, z is equal, that's nonsense. Now we need to make another equation as well.
20x plus 35y plus 5z plus 19.
And what kind of thing is that an equation? Seats, students, yeah, same difference, yeah.
Bums and seats.
So bums on seats. So if you've got x, one 20-seater, 20 by 1 seat, 20 by 1 seats. 2 of them, 20 by 2. 3 of them, 20 by 3. 4 of them, 20 by 4. X of them, 20 by x seats. That's how many seats in the 20-seaters, in the x 20-seaters. How many seats in the 35-seaters? Well, you've got 35 seaters by number of buses, and finally similar crack for the last one. So that's an equation in seats. So the first is an equation in buses, the second is an equation in seats/students. Write down the corresponding linear system and find the system's solution set. Okay, so off we go. We've written down the linear system and we're going to find it including a real parameter. That's just a parameter. So we have 1x, 1y, 1z equal to 18. Whoa. 18, no equals there. 20x plus 35y plus 65z equal to 990. We want to get 1, 0. How do I kill that 20? Yeah, so row 2 sent to itself minus 20 times row 1. So the first row is fine, 1, 1, 1, 18. 20 minus 20 times 1 is equal to 20 minus 20 is 0. 35 minus 20 times 1 is 35 minus 20, which is 15. And 65 minus 20 times 1 is equal to 65 minus 20 is 45. And last one is 990 minus 20 of those. I think that's going to be 630. Sounds good. So I have my 1, 0. I want to get a 1.
Row 1
Minus 15. Minus off.
Divided by 15 is sound. Is there an alternative?
There was you
Which
could
one
actually
should I
just
top
do
of
row
it?
1
1 over 15.
Minus 15 on 1?
Can you use row 1?
You can.
No,
Oh, you can't do
Oh,
one.
yeah,
You mess up your 0.
Right.
Okay. If you did row 2 minus 15 times row 1, this would you get 15 minus 50. You get a 0. Of course, you want a 1. So you'd say, "Oh, I'll take away 14 of them." Sure enough, you get 15 minus 14 is 1, but you'll get 0 minus 14. You get minus 14. So you pretty much always, I would say, to make ones, you'll always multiply and divide to make ones. I'll just say so. Well,
You
maybe.
put factor to get zeros in.
So let's write that down here. So zeros, you do a row to itself plus, or it could be plus as well, minus the pivot row. A multiple. The pivot row means the the pivot row means the row with the 1 for that column, and to make ones, you're always going to pretty much divide or multiply it. So I'll write multiply or divide by a constant. So to make zeros, you add or subtract the multiple of the pivot row. To make ones, you multiply or divide. So to make this 1, you divide by 15. So row 2 sent to row 2 divided by 15. Probably fit it here. 1x, 1y, 1z is equal to 18. 0 divided by 15 is 0. 15 divided by 15 is 1. 45 divided by 15 is 3. 630 divided by 15 is it 42? 42?
Yeah.
Okay. So that's Gauss elimination done because we have 1, 0, 1 done. Now you're asked, does that have solutions? Yeah.
Yes.
Now you look at parameters. Is x a parameter?
No.
Y a parameter?
No.
Z?
Yeah.
That's not a pivot. Okay. So Z can be anything. Now this question is set up a little better than the one we did, because the one we did, it basically just asks us to solve it, and we kind of have to figure out ourselves that x, y, and z number of buses has to be 0 or greater, and has to be a whole number. This question kind of does it for us because it says write down the corresponding linear system. So write this down, solve this away in part B, and then go back and think about buses in part C. So we'll just solve this abstractly.
Sorry, JB, why are you saying Z equals T then?
Because it has no, maybe I'll write it down here. No, Z is a pivotless column. There's no leading one in that one. Okay, so Z equal to T anyway, and now we're looking at the second row, which reads Y plus 3 times Z is equal to 42. And we know Z is equal to T. So we have Y plus 3T is equal to 42, and take away 3T from both sides. Y is equal to 42 minus 3T. And as I said, you can go a bit faster on that if you want. So for example, if you're going to take 10 65-seaters, you need to take 12 35-seaters, for example.
Sorry, did you explain the pivotless thing again? Sorry.
Say that again?
I know you just said that they're pivotless.
So when you have solutions,
Yeah.
every pivotless column corresponds to a parameter. So this has got a pivot, so x is not a parameter. Y has got a pivot, so y is not a parameter. Z has no pivot, so z is a parameter. Now look at the first row. The first row reads x, 1x plus 1y plus 1z is equal to 18. Let's say this time we'll take away the y and the z first. So x is equal to 18 minus y minus z. And we know what y and z are in terms of t anyway. So we have 18. Y is, careful the sign, 42 minus 3t. And z is minus t. And if we're careful there, we should handle this okay. Minus 3t is plus 3t. Minus t is 2t. And we have 18 minus 42. What's that? Is that 24? Yeah. Minus 24. So the abstract problem, the x plus y plus z equal to 18 and the 20x plus 35y plus 65z equal to 90. For each value of t, you get a different solution. And in terms of the abstract problem, what values of x, y, z solve that? Your z can be anything. As long as your y is related to your z like that and your x is related to your z like that, it'll give you a solution. But of course, we're going back to the problem. Find out how many of each type of bus could be leased by finding all. We only want the positive solutions. So we're trying to find values of t such that 2t minus 24, 42 minus 3t, and t are 0, 1, 2, so on and so forth. So we're trying to find values of t such that all of these are positive whole numbers. It can happen if I was a bit shoddy and didn't do it, but you could write down the thing that wouldn't work. I mean, for example, 18, if the number cease was more than 18 times 65, you'd end up, you couldn't actually make them all positive, something like that. Now, you're kind of on your own here, just to use your head really. There's no way. I would say I'd probably just start with t equals 0, t equals 1, t equals 2, and hopefully you'll see a pattern. If you're a little bit better, you can do a little bit better. You know that you can actually solve little, I'll just do that on the board because I wouldn't recommend that. I'd actually just, each you do it whatever way is natural to you. If it was myself, I'd probably do something like this. I need 2t minus 24 to be greater than or equal to 0. So I need 2t to be bigger than or equal to 24. And of course you could do that in your head as well, depending on how good you are with the numbers and that. So I certainly need t to be greater than or equal to 12 to satisfy the first one. For the second one, I need 42 minus 3t to be bigger than or equal to 0. So I need 42 to be bigger than or equal to 3t. Divide both sides by 3. I need 14 to be bigger than or equal to t. In other words, t has to be less than or equal to 14. And then the last one, well, I just need t to be bigger than or equal to 0. And the ones that are bigger than 12, bigger than 0, and less than 14 is 12, 13, 14. That's the smartest way to go about it, but I think I say that. Maybe I would just do t. Well, I'll just write down what you could do it. So you could say, look, I'll try t equals 0. What do you get? You get this would be minus 24 for x, 42 minus 3 times 0, 42 for y, and 0 for z. Does that work? Minus 24.
Minus 24.
No, so that's not working. Then maybe try a t equal to 1. And you kind of get, so that'd be 2 minus 24 is minus 22. 42 minus 3 times 1 is 39. And is that working?
No.
No. And then you'll kind of, this is what it'll be like. Clearly I need t to be at least 12.
The exam will be over, but then you got the right number.
Yeah, well you kind of cop at this stage. Look, I need t to be at least 12. So you try t equal to 12. And you get 2 by 12, 24 minus 24 is 0. That's okay. No 20-seaters. 42 minus 3 times 12, that's 42 minus 36, which I'm fairly sure is 6. And then t itself is 12. So you can have 6 35-seaters and 12 big ones. Now try maybe t equal to 13. So that'd be 2 by 13, 26 minus 24, that's 2 of the small ones. 42 minus 3 times 13 is 42 minus 39 is 3. 3 of the medium ones and 13 of the large ones. Then try t equal to 14. And you'd have 28 minus 24, that's 4 of the small ones. 42 minus 3 times 14, you'd end up with 0, and you know t can't be any bigger because this will go negative, so it's going to be the last one, and 14 of the large ones.
If you take that, like you have 12, 13, 14, whatever the numbers are, they'd be in
Well,
in
yeah.
future like that, yeah?
Well,
you
I mean,
couldn't have, let's say, 12, 15, 16, no? Find one there, like 2t minus 24 is the easiest one to sort of pick out straight away out of those 3. So then
I wouldn't make any
Wouldn't
comment.
make
I
any
just,
of that,
to be honest, when you're here, you're on your own. I think that's probably the fairest thing to say. You're able to figure it out.
So you're saying there's 3 answers there?
Yeah, that's it.
So, like if you're using t to 12 and t to 14, you only 2 types of buses, whereas it asks you to use 3 types of buses. So like t13 is the only one that satisfies the question. T equal to 13.
No, you're okay. They're okay. It's just saying they're available. 0 is positive. We can spend a long time talking about that, but 0 is positive. Right? Yeah, no, that'd be a bit, no, they're all okay. I mean, if you wrote down and said that's the only solution, I'm going to say, yeah, I'm going to give you the marks, of course.
If you only give one of them solutions, is that enough
No.
for marks? No, you have to do the dream.
Yeah.
13, 12, 13, 14.
Yeah. Because you're looking for all of them.
Yeah.
So one of them wouldn't be enough.
Nice.
Of course, it's not as if if you gave one of them you get no marks, because you've got all of part A, all of part B, and most of part C. Any questions on this?
So you said if you had T with 15 there, is that not satisfying as well?
No, this will be negative.
Oh, it'd be 45, sorry. Yeah, that's fine.
Now this is your Gauss-Jordan. Now I don't want confusion between Gauss-Jordan elimination and Gauss elimination, because this is a completely different question. The one earlier on where we had an issue between Gauss elimination and Gauss-Jordan. This is finding the inverse of a matrix, and this is a completely different question, finding the inverse of this. So what you need to do is set this up: 108, 253. 1, 2, 3. Now this is, I mean, as questions go, it's not very nice in a test or an exam situation. For time, you're going to be absolutely fine. So you will be able to take your time, and you will actually be able to check your answer maybe after doing all the questions. There's probably 3 or 4 questions that can come up if you look at